Hi, today I'm going to introduce a method to transform the molecular structure to the numeric representation so that we can perform quantitative analysis on moleculars. And this method is called extended connectivity fingerprints, short for ECFP. The first step for ECFP is the initial assigning of atom identifier. And this is done by getting the 6 properties of that atom listed here and applying a hash function to hash these numbers to a single integer called identifier. So here in the iteration 0, we'll get the identifier for each atom. 1, 2, 3, 4, 5, 6, and each atom will get its own identifier derived from their atom properties. And then is iterative updating of the identifier. So this step is from the single atom, it will increase the range and include more atoms, the neighboring atoms. So for this iteration 1, now we are from just carbon 1 to all the neighboring carbon 7, 6, and 2. And also a single integer will generate it called an identifier for this area to represent the features within this circle. And this has been done by hashing all identifiers within this area. So in this case, it's going to be hashing the identifier of carbon 1, 6, 7, 2 to a single integer. And then we can do iteration 2 and iteration 3 with the range keep increasing. So here, the example in the iteration 1 from the initial identifier, it will increase the range to include the neighboring number and got a new identifier, and the identifier of each atom will get updated. So by doing this, we will get a lot of features of the molecular from the initial identifier, like only a one bound between each atom, to like the iteration 1, we have more features include for the molecular, and keep doing until there's no more new identifier generated. And at that point, we already get all the features of that molecular. So the final step is the removal of the identifier duplication. So, for example, here, the center of the atom is oxygen, and here the center of the atom is the nitrogen. However, they still generate the same identifier. So in this case, we want to remove the duplication so that it won't cause any problem of adding some extra or feature redundancy. And this is how, in general, ECFP works.